So with the midterm coming around the corner, I wanted to make a couple videos of going through problems, just so you have something to come back to if you're ever unsure of something. So looking at this problem, you can see it's very similar to the quiz, and there's a purpose to that because it can kind of help you out if you want to look over your quiz early if you don't want to wait till Monday. So we have a 20 kilogram object being pulled at an angle of 35 degrees above the horizontal. If it is accelerating at 5 meters per second squared, what is the force of tension in the rope if the coefficient of friction is 0.15? So first off, we have a coefficient of friction equal to 0.15. We have a 20 kilogram object. It is accelerating at 5 meters per second squared. So we have a angled tension force that is 35 degrees above the horizontal. So we can break that into its x component, force tension x, and its y component, force tension y. So then we also have gravity. It's always a good place to start. And a normal force pushing back up against it, because it is sliding on the ground. And because it is sliding, we will have a force of friction pushing it backwards. Alright, so where do we want to start? Do we want to start in the x or in the y? Personally, since I know it is not accelerating in the y, I will start in the y, just because that is one less thing to worry about. So we have the sum of the forces in the y direction equals mass times acceleration in the y, except acceleration is 0. Now, our forces in the y are our force normal going up, plus our force tension, y, minus our force of gravity going down, equals 0. So let's plug in some numbers here. We got force normal, that'll stay the same, plus our force of tension times sine of theta, because it is in the y, minus mg equals 0. All right, looking at this, it doesn't look the best because we have force tension that we don't know, and we also have force normal that we don't know. So let's go to the x and see if this makes our lives any easier. Sum of the forces in the x equals our mass times our acceleration in the x. So looking at our force diagram, we have our force tension x minus our force of friction equals mass times acceleration. Alright, so let's plug some stuff in. Our force tension in the x is just force tension times the cosine of theta minus our force of friction. Our force of friction down here, as we all know, equals mu times the normal force. So we'll put mu times force normal equals mass times acceleration. Now looking at this, we still have two unknowns, I think. We have our force normal and our force of tension. So we have two equations and two variables. Unfortunately, this means we have to dive into algebra, I think. That's a scary term. So what we could do is we could do substitution. We could solve for force normal and then plug that into the other equation. Does that sound good? All right, so we have our force normal. I will subtract equals, I'll subtract this to the other side, so mg minus force tension sine of theta. Theta, by the way, is just our way of denouncing the angle. It is just a variable I can put in there instead of writing 35 every time. So now I have our force normal here and our force normal here. So I will plug in my force normal. So this is going to get a little long, so I'm going to come down here. So force tension cosine of theta minus mu times mg minus force tension sine of theta equals mass times acceleration. See, all I did here is I just put this force normal, put some brackets in it, and I put it right there. So here I see we only have one unknown now. So let's put in some numbers and see what we get. So I know cosine of 35, if I plug that into the calculator real quick, that would be 0.815 force of tension minus mu, which is 0.15, times mg, which is 20 times 9.8. Putting that into the calculator, that'd be 196 minus our force tension times sine of 35. Putting sine of 35 into the calculator real quick. This gives us 0.574 force tension. Let's close the parentheses there. Equals our mass of 20 times 5, which is 100. So we got to do a little bit more math here, unfortunately. We can distribute our 15. So we will get 0.819. Sorry, I missed. So that in the calculator wrong. Minus 29.4 minus 0.15 times 0.574, putting that into the calculator. But I also have to distribute this negative sign, so that makes that plus. .086 force tension equals 100. So all we have to do is combine like terms, add 29 to each. So that'll give us 0.905 force tension equals 129. This is what happens when you are thinking about multiple things at once. So divide through, so our force tension will equal 142.98 newtons. So let's zoom out a little here. So this is the problem we just did. So probably be a little bit more. This is a little bit more complicated than what we'd probably see on the midterm, but it is a good problem to show how we break down angled forces. We break them down into the x and into the y, and then how we use that to find. And so then how we break things down into the y plane and the x plane. And because we couldn't solve everything with the y plane, we ended up with two unknowns here in the y. So I had to switch to the x. That gives us, and then that also gave us two unknowns. So what you should take away from this is that you should always just keep trying different things. If one path doesn't work, don't throw it out the window. Just switch to a different plane or a different way of thinking that could possibly solve the problem that way. And so doing that, we was able to combine the two here, substitute in, and then from there I had one equation and one variable. From there it was just algebra, and we can all solve the algebra. All right, everybody, have a good day. I hope this helps, and good luck on the midterm coming up.